Can I start?
Sure.
So today was the first day of the CTF. In the morning, John and I arrived there fairly early to play one of the challenges. That challenge was special because every team got a time slot, one single time slot for that day, and so we had to come in early. Before we did that challenge, we got a hint and a video. So do you think we should watch the video first or the picture?
Let's go the video first.
It's 6 minutes.
Oh my gosh. It's just this for 6 minutes. There's no context. The stakes are really high for the CTF.
What do you think? How expensive were the stock footage?
Yeah.
Okay.
Dang.
G'day YouTube. So it's been a while since my last video.
It's my favorite
I
YouTuber.
apologise for that. We'll be back to a regular upload schedule real soon. But I'm Gadget Overflow. I'm Bogan. And today we've got a pretty fantastic unboxing video for you. Today we have this, which was sent to us by Google. And I'm not too sure what it is, but let's, she looks pretty big. Let's open it up and take a look. Oh, sweet! So, let's get this out of the way. That's just shit now. We don't want that. What we have here is this is a controller from that new Stadia thing that Google's coming to do. So, what the hell? Let's find out who that is and who's knocking on my lab door. Oh no.
Who is it? It's the sign.
Oh my gosh. Gotta be Daniel.
Oh, what the hell? Alright, okay then. Thanks, mate. Thanks for that. Weirdo. Alright then. So we got this new box here. Who cares about this Stadia shit now? Right, so this is mysterious and this is interesting. So let's find out what's in this box. So the thing is with this one, it came from some mob called Asus, and they're the motherboard manufacturer and they do all that kind of stuff. But on the delivery thing, they misspelled their own name. It was ASIS. That's really funny because how do you misspell your own name? It's like me misspelling Bo. It's B-O-U. I don't know. Anyway, let's move on to unboxing. And what the hell is this? What is going on?
Oh no.
This is not good. This is real bad. I'm gonna need some help with this.
So the hint looks like schematics, and I'm not too sharp on this sort of thing, right?
These are definitely PCB boards, and I assume that they implement this is whatever is shown on the schematic as well. But there are two different kinds of schematic. There's one down here, right check, which we don't really see what's on there.
No.
And then we have this up here, which only shows part of it. And then we noticed that there it says
Dip switches, right?
Yeah.
Yeah.
So that might be for input dips, switches.
Mm-hmm.
Yeah. I quickly Googled the chip numbers. So this here is just a serial register.
Okay.
And then it has these out pins that go into this thing here. And this is a 7-segment display.
Okay, cool. So
Yeah.
a 7-segment display might be...
And in the schematic it's also 7 segments.
Oh, that's
so
true.
That makes sense.
Nice.
Okay, so what we know is there are dip switches as inputs, a 7-segment display output. which also has here this power flag. So maybe the 7-segment display is the flag output.
I wonder if that should be interpreted as flag, literally the flag, or like another interpretation of flag, like, okay, assembly instruction set, it sets the 0 flag or something.
That makes sense too. Have you seen this VR bomb game?
No. Is
The
that a
VR
thing?
B game?
Yeah, the B word.
Yeah, I can show you. Keep talking and nobody explodes, is it called?
Oh, I have seen that.
The second to last is a black wire, the last wire is a red wire, and the
Gotcha.
time is on 3:07. And then somebody can look up in the book, okay, when the time is above 3, you have to cut the black cable or something. And so there's this communication back and forth.
Nice.
So I wonder if it's like a version of that. All right. We have a couple of minutes left before the CTF. So John quickly went downstairs, letting his significant other into the building. And then we will meet in the lobby to do the challenge thing. So I've heard that Google thinks every team will solve this challenge. And so I'm a little bit nervous that we won't be solving this challenge. That would be a bit embarrassing, maybe. So let's see how it goes. I don't know how well play tested they have it and how much of hardware knowledge is actually required, because John does have some experience as far as I know. Like he can somewhat read a schematic, and I have a little bit more experience, for example, from building the 8-bit computer on stream. But also, like, I'm not like super experienced. I don't know if I can like quickly understand a schematic to figure out the gates, and I assume it's rather more complicated than just a basic, like 2 switches, which switches have to be turned on or so. So it's a Google CTF after all. So no clue. Okay, John will be outside with laptops, and I will go inside, and I don't know what's going to be in there. Yeah. I'm ready. Do I get any special introduction or anything?
Hi. Come this way. Oh, you're a Google. Come.
Okay. Oh shit. Hello. Okay. What do I have to do? Sit down?
Please take a seat. We're waiting for your remote team to be in place. Repeat.
Room is ready. Okay. So the device has a counter. It's counting down from like 19,000, so I guess time limit maybe. The dip switches are connected to some stuff, and then there's another button called check password, and there is an LED which might be the password of K output maybe. There are also some components, some capacitors and some LEDs. Oh, maybe we can slow down the clock. So this is basically what I tried to do is the NE55 in the top left corner of the board has 2 capacitors. Originally there was 100 NF and 10 NF, and that is providing a clock which is responsible for the countdown. And you can decide how fast the countdown goes with configuring these capacitors. And so I was wondering with an online calculator what makes it slower, because I don't quite know how it's exactly configured.
You had already tried all the kind of different combinations with the 100 NF or 10 NF and the resistors there. It looks like the R32, R33.
We died.
Yeah.
Are you still there, buddy? I died. That challenge was basically a defuse the bomb challenge. You were led into like this dark room with smoke and light, and it's like super dark, and you get this box and there's a bomb inside. They really tried to make like a scary theme out of this. We had a walkie-talkie, and John and Caitlin were upstairs and they couldn't see anything. They were only able to communicate with me through the walkie-talkie. And so I guess my task was to describe the bomb. Very clearly there are dip switches, and there's a button called check password that you can press, and so you just need to find the correct combination of dip switches for the input. And only certain components of that bomb were kind of like exposed to you. And one particular part, there was an NE555 timer, which we actually know a little bit about from my Twitch streaming, where I was building this 8-bit computer, because there was also a clock module, so we got to know that chip. And Ben Eder, in that video series that we watched, also explained that how that like internally works, and I knew that larger capacitors make the clock run slower. And so I thought about trying to like exchange or I don't know, modify somehow these capacitors so that the bomb ticks a lot slower and we get more time. The problem is when you like pull out one, the clock runs very, very fast. There was a multimeter to measure the capacitance of the capacitors. But the problem was when I was measuring them, they all showed like 0.02. And so I kind of like tried brute force, and I noticed that at some it got faster and at some it got slower, but I wasn't sure if this was the slowest. Like that was kind of like my biggest problem. I figured out a kind of slow configuration, but I felt like, oh, maybe I can make it even slower or even stop it. So I even at some point had this idea, maybe I can kind of like use the diodes to stop the flow of current in a certain direction, and maybe that even stops the NE55 timer. That was a kind of a weird idea I had at some point, but I don't think it worked. It didn't work out. At some point I realized that the multimeter had the plugs in the wrong place, so it was on for measuring voltage, I believe, but you had to plug it in to the other input of the multimeter to measure capacitance. And when I found that out, I was able to measure which one is the higher capacitor, and then I plugged it in at one point, and then it got slower. But at this point we already lost a lot of time, and I believe we had like 5 minutes left or so. During all of this, it was like very nerve-wracking because you constantly had this timer and a beeping going on, and it was making me really nervous. So once in a while I tried to do something else. And so, for example, I gave the chip numbers through to John with the walkie-talkie, and they were then Googling for the chip. And so there was an OR gate, as well as a CMOS thing, but that sounded weird, like what would the CMOS be? So at this point I didn't quite know what the CMOS chip was there. I did notice that at the end you had like the transistors connected together, very similar to like the blocky challenge or the mind test challenge. They are all like ended together at the end, and then they have to be a 1 for the password. And then there was one other thing. There was a table with 6 bits to 4 bits. In the cells, like always 2 bits, and I don't know what they are for. So this is kind of like what happened like during the challenge, and then obviously we failed, the bomb exploded. So I was kind of worried that other teams would solve it right away, and it would be super embarrassing for us. YouTube celebrities invited, we are not actually like good at anything. Throughout the day I've been thinking a bit more about the challenge, and I think I have a better plan now for tomorrow, and I kind of know what we have to do. So first of all, the CMOS chip was actually an XOR gate. So now we know we have the AND gates, which are the transistors. We have an XOR component. I don't know exactly how many inputs and outputs, but that's XOR. And then we have this OR chip. So from that, we should be able to kind of match all the dip switch inputs through all these logic gates to the outputs. And so that would be kind of straightforward. It would just be work, right? And you have this time pressure, so you need to be kind of fast with that. I wonder how we would do this with the walkie-talkie, because the person going into the room, I don't think can take anything with them. So if I go in there, I can't make notes, I can't draw this myself. So I would kind of have to like describe the circuit and all the connections to John and Caitlin upstairs, which might work. So my idea is maybe to talk to them how we communicate, like make a plan how to effectively communicate this so that they understand if I say something what I mean with that. So we plan that, and then I can just give out all the things. I noticed that all the components should have names, so it should be easy to say things like dip 1 is connected to transistor, I believe was like U1 or so, and then output of U1 goes into so, and then they can draw it too. So now at the end of the day, I also know that no other team solved it yet, but some teams apparently got fairly close, and it's very clear that tomorrow several teams should be able to solve it. Okay, so you have hardware experience?
Yeah, a little bit, like hobbyist level electronic stuff. So first thing I found was that we could switch the capacitors of the timer, and with that we could let it run slower. That was a big thing, so instead of 13 minutes we would have like probably the full 45 minutes we would have given. Well, wouldn't I have accidentally lowered that time quite a lot? I have experience with the timer, but I don't know the layout from it. But my colleague was also having a laptop over the radio, and he told me which pin is which, and so I figured out which capacitor to switch, and yeah, I got the bump to run a bit slower. Well, I tried to decipher the whole logic stuff, and at the end I was wondering if I couldn't just cut the wire, but then the bump exploded.
Do you have any experience with electronics?
Oh, very simple one, like breadboard with breadboard. But I don't know what to do, so I pick up some condenser. I don't know, but then timer goes down faster. So I should figure out how to start timer. Then, but this time we failed.
Yeah.
So
What did you tell the team upstairs?
I don't know what to tell my teammates. And these are
I also failed. And then I looked and I saw that this one is connected to this down here, because this one also has like a disconnected one. But how does this, like, these are all like disconnected. Like, where are these connected to?
I don't know.
Ah, but okay, wait. Now that I see that all of them are not connected, maybe
All
they
of
are
them
all.
are not
Maybe they are all.
zero. I don't know. Ground, which would be zero, but it would make sense because that means they're all going to be
Yeah.
zeros going into the OR gate.
Exactly. When I started out, I was very worried to pull out any capacitors because I was worried that it would immediately do something.
I think it said you.
Or when I
did-
pressed the button wrong, it would like.
I think it said it would explode if you did that, according to this video at the end.
Oh, really?
Yeah. So. Maybe there's like two different approaches. You could either use the truth table and like try, or you could do, or if you knew how like the schematic worked, maybe it's like, maybe it allows you teams to try either using the truth tables or not, because yeah, I feel like you don't have. I don't know. Maybe you don't. Maybe you do. I feel like you don't have to use the truth tables unless they help you figure out that those are not zeros. So maybe like those are something else. I don't know.
Maybe, yeah. So we are getting now a second attempt at the bomb challenge. We are ready. We have some notebooks to write down for John and Caitlin upstairs, and I will go in there. Why does Google have this? All right. Okay,
No, nothing can go wrong, yes.
let's do this. Can I start?
Sure.
Can you confirm bomb has been delivered?
Okay, I got the bump. I changed the capacitors for the timer now. Okay, this was harder than anticipated. Okay, I got the timer now. Okay, so let's do this. Dip 1 connected to A of an AND gate, Q1. Dip 2 goes directly to the output Q7. Dip 3 goes to the A input of Q2, AND gate. Dip 4 goes to the XOR gate U2. I think you need to look up for me the pin out of the XOR gate. Can you search for 74 LVC 2G86? Dip 9 and 2 disappear into the PCB. I need to find where the trace goes. Okay, pin 9 also goes to the XOR, but I don't know to which XOR gate this belongs to. Which things are connected to XOR?
For the XOR, you have DIP 4 as input, DIP 9, and DIP 10. DIP 9 and DIP 10 are the ones we don't know about yet.
Oh, I think the output of Q3 also goes to the second XOR input. So we should have now both gates complete with 4 inputs.
4 0 5 0 6 1 7 0 8 1 9 1 10 1.
Okay. So it's okay. So, okay, I did this now. Should I? Okay, I can press this check password thing now. I don't know if that already does it, or if we should also manipulate the cables. Okay, I fucked up. Okay, I pressed the password. This was wrong, and it subtracted time, and now we are running out of time. Okay, was nice. Thank you for your help. See you on the other side.
281.
No, forget it. We have 4, 3, 2. It counts a bit slower. 1. That was it. Bye bye.
Actually,
Nice.
that's pretty good.
Yeah.
So somewhere he said we were on the right track. It was when we were tracing out the end dip switch, what we needed. He did say it had to be high though, so it was supposed to be ones.
Like that picture with this bomb spot person standing there, then Eduardo coming out. So, what's your name?
I'm Kevin.
You made the bomb challenge.
Correct.
Okay. So how did you come up with the idea?
Well, I think 2 years ago we had a slot machine challenge because we were like at lunch and we're thinking, okay, what would be a cool hardware challenge to have? Can we have a slot machine? Yeah, sure. Okay, then we made the slot machine. And I think this time someone was joking about, hey, how about a bomb this time? And everyone knows, keep talking, nobody explodes. So I thought like, but I want to have it like a little bit more realistic, right?
So when you designed this, what were your parameters? Like, was it from the beginning about communication or?
This certainly was one aspect, which also was very hard for me to estimate how hard it will be. Because it's like the most difficult part during Keep Talking, Nobody Explodes, right? It's how can you communicate efficiently? And so I thought, maybe I'll try to make it rather easy, and it still turned out way too hard to be way too hard. So I made it easier and easier until people were actually able to solve it.
How can you make it easier or harder? Like, what does affect the difficulty?
The amount of ICs that you're using. So I only have like 2 ICs in there, and I made it so that you can try to pattern match the board. So you can see at the end there was like a chain of couple of transistors, and each of them feed into another one. So this should be a very obvious end. And yeah, and the inverter should also be, okay, you see, okay, some resistor, yeah, this might be inverting. And then the more complicated ones I used dedicated ICs for, where you could look up the part numbers. Yeah, and the amount of transistors also was kept rather low. This is also why there's not one unique answer to this, but 64, because I wanted to keep it rather simple.
We are now on the second day, so we had a full day of all the teams going through it already. What was your experience seeing the teams attempting it?
Teams had rather different approaches, actually. It was very fun to just see what some of the teams do. Some of them were pretty efficient and was saying, yeah, this connects here and there, and I think they got like almost a full schematic after the first day.
Oh, wow.
Other teams were looking at it, and after 2 minutes were like, okay, what should I do here? And that was also interesting, that they, apparently not the first thing that came into their mind, okay, I need to diffuse this.
So the bomb had multiple components. There were 7 segment displays as outputs. There was that was basically a timer. There were some wires and the logic gates themselves. Can you say something about the different parts and how they interact with each other?
There was basically the 7 segment displays that were connected to shift registers, which are just to show the time. And then there were a couple of optocouplers, which are just there that you don't short out the main board, because it should not crash then, right? It would be easy. Which is also the reason why it has 2 power supplies in the bottom. Yeah, and actually probably people got confused by that. Okay, what is this I see? I actually made it obvious. It's like a box and saying overload protection, right?
Yeah.
Yeah, then we have a 5x5 timer, which generates a clock roughly 50 hertz, which is used to basically count down. And yeah, the logic part. And 2 wires.
You said you watched like 3 teams. Were they approaching the timer at all, or how did they approach the timer?
Yeah, so they were thinking, okay, I need there's 5x5 timer generation, so maybe we can mess with it. I think bigger capacitor or something like this. So they tried to measure the capacity with the multimeter that I gave them, which worked more or less, but in the end they just swapped it and looked what happens. And it was pretty interesting because one team actually managed to connect like the 2 biggest ones and were able to extend the time beyond what was intended. I actually had to fix this now during the night. It didn't wasn't an issue yesterday because I figured it out like 1 minute before they exploded. So
yeah, I noticed on the PCB there's, or at least on the schematic, there will look like something like an antenna. Or
yes.
What is that about?
Nothing. It's just.
Also, I heard from Gunwell that there's a little bit of a story with how you transported this to here, because you are not based here in London with the device. I imagine if you had traveled with that through the airport, it would have been weird.
Yeah, so it's also, you cannot say like in the customs, yeah, I'm transporting a bomb for an event. That's difficult. So what we in the end did, we shipped the PCBs here with like Google shipping and ordered the components here. And then we had like some soldering action going on the day before the CTF, basically until I think 1 a.m. or something. And
was it just soldering work, and was everything like, were you confident that the whole thing would work?
Of course, everything works perfectly.
Google perfectly.
So what you probably also saw on the board is that this one IC wasn't actually soldered on the PCB, but connected with some tiny 0.1 millimeter wires to some breakout board, and there was something soldered in there. When I created the board, I messed up the footprint, and this IC is not available in this dimension. It was actually a different IC, but it had the same pinout. Luckily, no one got confused by that so far. Yeah, but this was one, oh shit, now we have like 20 PCBs of this, and it won't fit.
So there was a video and a hint given. The video didn't include any hints, it was just for fun, but the hint, you place some of the schematic and the board in some way, so a lot of stuff was covered, but a few things were, I guess, deliberately showing. What was the idea behind what you showed and not showed?
So on the one paper you could see basically the 5x5 timer and like 2 capacitors, some resistors. So with this you could actually do already the math, see, okay, it's running at I think 48 hertz, blah blah. And also I think, did it say external clock or something? I'm not quite sure, but this should already hint, okay, maybe we can mess with it. And then you should see like some parts of the password protection logic. You see like there are transistors. I think it actually shows you the part number of the transistor. And then on the other side, on a different paper, you saw like password OK output or something. So this should have hinted to transistor logic. I was actually expecting everyone to come in here with the first attempt like, okay, transistors, okay, this pattern match, this might be an inverter. And so for me, I was afraid that it's too easy. But of course, it was not.
Yeah.
It's just, if you know the challenge, it's trivial. If you don't know it and you don't know what to expect, I think it's super hard.
Do something scary.
Okay, ready? We're coming in.
Now all teams have completed the bomb challenge, and we will deliver the flags to the teams which have solved the challenge successfully in the order of the least time of solve. Okay, the flag has been delivered. Thank you. All the flags have now been delivered.
So this is the sketchy setup.
Please do not photograph the batteries. Just joking. Right?
I heard.
What happened to P4? Well, they had the right cap in, and then they had a second thought about it, and they pulled it out. Started experimenting with other ones, but all the others were going faster. So they wanted to put back the good one, like the slow one, and it fell inside.
Okay. Oh no!
Isn't it the same as Dragon Sector pretty much?
Yeah, kind of.
Yeah, that's pretty similar actually.
What happened? Did it also fall?
All the Polish teams dropped the cap.
No, really? Okay, I didn't think about that problem. But
Did I also try to attach both of them, or?
No.
Okay.
oh, there was a pen?
Yeah.
Oh, fuck! I could have drawn it myself the whole time.
Wait, you were looking at the board? There's no point in looking at the board.
No, I looked at the sheet, but I gave the because I can't remember all of it, like all the gates, and to figure it out. I was giving the schematic with the walkie-talkie upstairs, and they drew it based on my description. But if I had just a pen, I would have just drawn it myself.
This is basically a 5x5 timer, which you can see also on the hint, which gives a signal via this connection to this chip, whatever, and this controls the countdown. So they also had like a small bag of capacitors, so they switched, or they were supposed to switch one of them to gain like 2 times the time.
Right.
So from 20 minutes go up to 40 with 45 minutes time slots, right? Makes sense. And then you have like this box that says password protection and a button check password and like the switches. So you basically reverse this part, find a valid password, and press the button, and it will show you a yes or beep, basically. That was also tricky because you might not know which is on, which is off, which you can measure with the multimeter, basically. And you also don't know, then you get to the right password, and then you have like this document which says like, yeah, this is your password, and then which wire to cut. So here you have like, your password is 6 A's and 4 B's, and then you look up, okay, which is it, and then you get like a 2-digit key which says like cut white wire, cut black one.
Okay.
And this is actually a little bit tricky because then you don't know, okay, do I enter the digit or is the number to be read like this?
Yeah.
Or like this? And there are 64 solutions though to this, and some of them are palindromes. So you can actually find one that is the same either way, and then you figure out to cut the black wire. And as soon as you cut the black wire, you're done.
Okay. So the solution is cut the black wire.
Enter right password.
Oh, do you have to put the right
and
password
then
in first?
cut the wire, yes.
Okay.
I
Cool.
mean, but if you cut the wrong wire at any point, it will explode.
Right, yeah.
Could I have, because you listed all the solutions with the black wire on there, could I have looked on the table which one is only cutting the black wire and then read the solution?
So if you do statistic analysis on this one, there is a higher chance for the cut black wires, because all of the data is random, unless for those who are valid solutions, and they are always black. So
if I had gone through a couple of the black solutions, I might have had a good chance, or is there too many? I don't know.
I think there are too many. I mean, you have 1,000 solutions there. Let's subtract 64 from this. We're at least 900.
Okay.
And let's say
So
1/4 of them would be also cut black. So I'm not good at my statistics.
So this is the A's and B's actually represent just the switch positions.
Yes, basically it says like split it after 6 digits and 4.
The
And
A and B doesn't actually mean anything. It's just a way of
it's
splitting them.
exactly. Then you have like A arrow down, B arrow right.
Okay, and any of these are correct solutions?
No, I mean, again, 64 passwords are correct out of all possibilities. Like you have 10 bits, and all of the valid ones will show you to cut the black ones. And the rest is filled with random data.
But you don't know if it's which way up it is.
I'm
turning
you
the
don't,
paper
you don't, let's say the last one is on from this side. You don't know if it's 0000001 or if it's 1000000.
Is that the mistake the one team made, or was it that the team upstairs gave it the wrong direction for those pins already?
No. So I actually checked. The team did not have the right password.
Ah, okay.
Or not. The one team did not press the check password button to verify whether the password is correct in the first place. So actually we had a VRP researcher team which did it, and they were confused about this, or they would have done it other way around, because something that we noticed afterwards is basically there are numbers below the switches.
Wait, where?
Below the dip switch, it shows you numbers.
Oh yeah, these numbers.
So they were thinking, oh, it's like this. But if you look at the countdown, it's like this.
Yeah.
And you actually had to read it like this.
Yeah.
So, but because they were the first one to get this far, we just told all teams afterwards, the numbers of on the dip switches have no meaning. So that they get the hint, okay, we don't know in which direction it is. And
to get the password, I'm presuming the only method is brute force?
No. Every time you enter an incorrect password, it will subtract 1 minute from it. So, but you see like those ICs, right? Like this is an OR gate, if I recall correctly. This is an XOR.
Oh, you can reverse it. Okay.
Yes. You also had like
makes sense.
This thing where you can see connections.
Yep.
And if you look at transistor logic before, you would see, okay, those are in a chain, so this is probably an AND. And there you have like some transistor and some resistors, and actually in an inverting position.
Okay, so
and then you basically could pattern match and see, okay, how it's connected and.
Yep. Cool.
So the team that won.
So the circuit itself actually looks fairly straightforward.
Yes.
I mean, it really depends on what this IC does.
Yeah, this should be the OR gate.
Okay, that's just an OR
like
gate.
4 times 2-pin OR.
Mm-hmm.
And this is like 2 times 2-pin XOR.
Okay, and they would have, if they'd worked out to put the right capacitor in.
No, the capacitors just to give them more time.
Yeah, but if they worked that out, then
so the VRP team that solved it did not mess with the timer at all.
Right.
So after the first day, they had basically the logic stuff worked out, and then overnight they found a valid password and tried it the next day, and yeah.
Cool. That looks really fun.
Yeah, damn it, you should have seen it live. So this is the Having a Blast challenge, which was the bomb room. And you probably first had a look at the PCB. It's all like weird stuff like optocouplers and shift registers. So they actually were not important for the challenge. We're just making sure that you don't short something out. Then you saw a 5x5 timer also on the hint, which should hint in the direction of changing capacitors. That actually gave you 2 times 20 minutes time. And then you had dip switches in the password protection area. So the idea was also on the hint that you figure out, okay, there's like a transistor logic going on in there, and figure out, okay, inverter, then we had OR, XOR and AND, and by reversing this, you would get out a valid password. You enter this, press the button, it shows the password okay, then you use the table that was provided to figure out which wire to cut.